They're asking you for the first partial derivative. You can think of this as an n variable function. Does much change when you're doing the partial derivatives? Not really. You're not. So what they're really asking you for is this. They're asking you for u sub x sub I. So for example, if you did this, each of these is logistically, the same type of thing happens when you're taking the derivative with respect to just one of them, because each one of them is underneath the root, and each one of them is squared. So if you did, for example, think of it in terms of the first one. If you think of it in terms of the first one, let's say you wanted to do it, let's say we wanted to do this right here, d sub x, u sub x1 like this, it would be equal to 1/2 times 2x1 plus x2 squared plus all the way up to xn squared to the what power? Negative 1/2 times what? Oh wait, no, I'm sorry. I don't need to do that. I'm sorry. It's x1 squared, then times what? 2x1, right? So if you simplify this, what cancels? 2. So you end up with x1 over the square root of what? x1 squared plus x2 squared all the way up to x sub n, not x to the n, x sub, no, it's okay, x sub n squared, right? Now what happens if I did that with respect to x2 or x3 or x4? Does anything change? No, it does, nothing changes. So u sub xi is just going to be x sub I over what? The square root of squared plus x2 plus n squared. That's the only thing that changes. No matter which one you do, it's just going to be whatever one you chose on top over the square root of that whole thing. The 2 cancels because each time you do this, that 2 is always going to appear. And it'll always cancel because 2 over 2 is always going to be 1. Exactly. That's it. Yeah, so
What does I mean?
I means it could be any of these. Now look, so I goes from 1 to n. You can pick one of them. Depending on, here's your I value, here's the first one, the second one, all the way up to n. It's an index variable. You saw these before. Where have you seen index variables? You've seen them. Before you did integration, before you did Riemann sums, you had like a lot of pieces to add together, right? And you broke them up and you wrote them as limits. So you wrote the limit. How many times did you write this? The limit as I goes to, as n goes to infinity, right? As n goes to infinity. Well, when you specified a slice, you generally specified it as the ith slice. I goes from 1 to infinity. It's just an index variable. You also see it in sigma notation, which is going to be the exact same thing. We've seen this picture before. What's the new thing that we've added into this picture?
A plane.
A plane, right. Those lines like T1 and T2, what the slope of T1 is what?
T1.
The partial derivative with respect to x. Thank you, right over there. Good job. And what's T2? The slope is partial with respect to y. Exactly. So essentially, if you create the plane that contains these two lines, what do you end up with? The tangent plane. The tangent plane. Exactly. So that's what we're going to be looking at. Equals 4x, right? Fy xy is equal to 2y. So fx at 1, 1, 1, 1, 3. What's that going to be equal to? 4. Fy at 1, 1, 3 is going to be equal to 2. So remember the equation we had was z minus z naught equals fx at x naught y naught times what? X minus a, right? Or x minus x naught, sorry. And fy x naught y naught times y naught. Exactly, right. So z minus, what's our z naught? 3 is equal to 4 times x minus
1
plus
2
times what? Y minus 1. And you are done. You've now found the equation of the plane of tangency. Yes, go ahead.
Unless we're planning on moving further.
Yeah, what's one of them? What's it going to be?
Negative x over root 4 minus x squared minus.
Yep. And then what's fy? Anybody have fy?
Fy is
Jeff, yeah, go ahead.
Negative 2y.
Yep.
Over the square root of 4 minus x squared plus 2y.
Minus 2y squared, right? Yeah. So then you want to do it at those points, at that point, right? So what do you get for the first one? What's fx evaluated at 1, negative 1? 1. Negative 1 over root 2? And what's the next one? Negative root 2. So we have,
That's just negative 1.
it's just, what, root 2 on the last one? Right here? Is it do people agree with this? Jerry? Do we agree with this or not? You need to take a position. This isn't like the American voting system where you can just be apathetic and...
It is just 1.
Okay, so you don't agree. Okay, good. We'll pause this while we figure this out.
Ones that show up as
Mhm.
shortcuts.
Okay, so it's just really fill in the blank for that. That's it.